See Lindelof videos, AP Calculus, differentiation of ln and exponential functions. I guess I want to talk about this first. One of my favorite derivatives is e to the x because the first derivative of e to the x is e to the x. However, if we get e to the f of x, we have to do something a little bit different. We get e to the f of x times f prime at x. So let's just work this out a little bit. So as I take my derivative, the first thing I'm going to do is just rewrite the obvious, which is this. So remember, its derivative, it's its own derivative, but now we need the derivative of this inside piece. So the derivative of 2x cubed is 6x squared, isn't it? From there, believe it or not, we're actually done with this one, that y prime is equal to 6x squared e to the 2x cubed. And that should be that. Let's take a look at just one other one that's similar, that I think not much more difficult. And that is that let y equal e to the e to the 3x squared, I guess. I like that one. I like that one, I think. I'm going to do the same thing here. I'm going to rewrite this as I take its derivative. I know part of its derivative is itself, so I'll take e to the 3x squared times the derivative of this. Right? Now I need the derivative of this mess. And the derivative of this mess starts out just being itself, doesn't it? Which is e to the 3x squared, right? To the 3x squared. I am missing this e here. That is the difference there, isn't it? Times the derivative of the top part. And the derivative of the top part is just 6x, isn't it? So I'm taking the derivative of this piece, which is just 6x. And that is my derivative. Now, what you'll see a lot, especially on the AP exam, is they'll simplify this and they'll say we have e to the 3x squared plus 3x squared times 6x. And this is just rules of exponents here, isn't it? So I hope this is helpful. If you have any questions or comments, let me know.